Alrighty, welcome to the last major topic of Chapter 9. This is going to be all about the quadratic formula. In this video, we're just going to start with the formula already given to us and learn what it means and how to use it. There's a separate bonus video showing how to get the formula from basic principles that's going to be required for honors and optional for everyone else. So let's start right off. The quadratic formula is a vocab word, of course, and an equation. It's a formula that helps you find the roots for any quadratic that's in standard form. So you remember that when you're in standard form, this means you have a quadratic given like ax squared plus bx plus c. Okay? So the quadratic formula uses these values a, b, and c, which determine what your parabola is doing, and they plug into this equation and they find out where the two roots are. Remember, the roots are the x-intercepts. So this formula is a little bit bigger and more complicated than most of the other formulas you have learned. However, it's extremely powerful, and so we don't have to memorize it, but it's very beneficial to us if we memorize it. So the formula is the roots or x-coordinates are negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And our good friend Steve has actually created a song which helps make this easier to remember. So since I'm at home and not embarrassed or shy, I can sing the little song to you without any music, of course, because I don't have a guitar. And then hopefully it will help stick in your mind. So it goes the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so if you get that little rhythm in your head, and maybe we should bring Steve in during homeroom or during class, and he can sing it actually playing the guitar, in which case it will probably sound a lot better. But if you get that kind of say it in your head over and over and over, it actually becomes pretty easy to remember. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And just like that. So say it over and over, and you'll have it memorized in no time. Every time you use it, if you sing that to yourself one time, I guarantee you'll have it by the end of the first homework assignment. Okay, the second vocabulary word for this section is discriminant. So the discriminant is a subsection of the formula. In fact, it's the b squared minus 4ac part of this equation. It's the part that shows up under the square root symbol. Okay, and the reason this part is important is because this part under the radical leads to how many solutions there are going to be. Okay, if the part under the radical is positive, you end up getting two solutions, because you're going to have negative b plus that amount or negative b minus that amount, and that will give you two different results. If the part under the square root, the b squared minus 4ac, is exactly equal to 0, then you're only going to have one solution, and it will be the double root. The reason is because if this part is 0, when you add or subtract it, you get the same thing, in which case your answer is going to come out to be the same, and it's called the double root, two of the same answer. And lastly, if under the radical you have a b squared minus 4ac that comes out to be negative, well, you cannot take the square root of a negative number, and therefore your parabola will have no real solutions. Okay, so this one here is going to be a parabola that crosses the x-axis twice. This one is going to be a parabola that crosses just one time, and then this one is going to be a parabola that's maybe located up here that doesn't cross at all, so no roots. Alright, problem solving tips. First one, write the equation in standard form. This is a pretty obvious one, but sometimes we forget. This only works if you have the equation in standard form. So if you have something that starts off, say, x squared plus 3x equals negative 10. This is not in standard form, and therefore you cannot start the quadratic formula. First, you would need to move this 10 over to the other side. So say plus 10 plus 10. Okay, and then you would get it correctly as x squared plus 3x plus 10 equals 0. Now this part here is in standard form, and you can identify your a value as 1, your b value is 3, and your c value is 10. The reason this is important is because if you leave the 10 on the wrong side, it's a negative instead of a positive, and then the entire result will be thrown off. Second thing you should do once you write it in standard form is identify the a value, the b value, and the c value. And by identify, I mean you actually write it down. So for this one, if we're carrying through our example, we write a equals 1, b equals 3, and c equals 10. This is part of showing your work, And just like all the other times that I share examples from the past with you guys, the students who do not write this down, you'll still get it right most of the time, but you'll make mistakes and you won't be able to see where and why you made them because you didn't show what you were plugging in. You might plug B in for A or A in for B, or you might plug C in upside down or backwards, and if you don't write down what your A, B, and C were, it's really, really hard to tell where you went wrong in the equation when your final answer comes out wrong. So write down A, B, and C for each quadratic that you're using. Then you plug in those three values into the equation and you simplify following PEMDAS. Okay, so at that point you're done, you've got your two answers. But one good thing to remember is your vertex is at negative b over 2a, so your two answers should come out symmetrical around the vertex. So for example, if your vertex is here, this is your vertex, say this should be R1 and this should be R2. If both R1 and R2, the values you get out of the quadratic formula, are both smaller than the vertex, or both larger than the vertex, or somehow not distributed symmetrically on either side of the vertex, then you know you've either made a mistake finding the vertex or you've made a mistake finding those two roots, because this relationship is always preserved. The vertex is halfway between the two roots. And lastly, if you get a negative discriminant, you're done. You can stop because there's going to be no solution, as we saw in the previous slide. So all we're going to do here is a couple of examples and then set you loose on the homework. Alright, let's try to do number 15. It says, state the value of the discriminant, then determine the number of real solutions. So the discriminant, remember, is the b squared minus 4ac. So let's identify our things. What is a? A is the coefficient in front here, which is a 1. B is the coefficient of the middle term, which is a 4. And c is the coefficient at the end, which is 3. So if I plug this stuff in right here, I get b squared, which is 4 squared, which is 16, minus 4, multiplied by a, which is 1, multiplied by c, which is 3. Okay, so that's 16 minus 4 times 1 times 3 is 12, which equals 4. Okay, because this is a positive number, that means I'm going to have two solutions. Excellent. Okay, let's go ahead and try to do number 16. A is 1, the coefficient here. B is 2, the coefficient here. And C is 1. So if I plug them into the formula b squared minus 4ac, and you'll notice that I rewrite the equation b squared minus 4ac each time before I plug my numbers in. Again, this is just another way to help ensure that you don't make a mistake. Because if you see b squared and you wrote down b equals 2, you're a lot more likely to plug it in correctly. 2 squared is 4 minus 4 times 1 times 1. 4 minus 4 is 0. So this has only one solution. Okay, and it's in fact going to be a double root. Another way you could have seen this was you might have noticed this is a perfect square, and it can be factored into x plus 1 squared. And we learned that this means shifted left 1. So the vertex is shifted left 1, which means it's still on the x-axis, which means there's only one solution. So again, all the things that we're learning here, they all tie into each other in kind of cool ways, so that if you forget one thing and you remember something else, you can still work your way towards that solution. Okay, let's try this one. Number 17. Our a value is again 1, b value is negative 4, and c value is 10. So our discriminant, b squared minus 4ac, b squared is negative 4 squared, which is positive 16, minus 4 times a is 1, times c is 10. So this is going to be 16 minus 40, which is negative 24. Okay, negative 24 tells us, since it's negative, there's no solutions. And now if we were to graph this parabola, it would never cross the y-axis. So you can always graph these in Desmos as well if you think that would be helpful. Alright, moving right along. Now we're actually going to use, state the value of the discriminant for each equation, then determine the number of solutions. That's the same directions. Okay, let's cancel these directions and say, get the roots. That's what I meant it to be, sorry. Let's say, get the roots. Okay, so let's just try two of them. Let's try number 1 first. So let's identify the a, b, and c. So a is going to equal what? The coefficient here is a 3. b is going to equal the coefficient here, which is a 2, and c is the coefficient here, which is a negative 3. Then we're going to write the equation. So here we're going to say the x roots is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we can plug in our numbers. So this is a lot of arithmetic and PEMDAS, and it's something that if you go through and you rush, you're more likely to make a mistake. So let's be slow and steady wins the race here. Negative b is going to be negative 2 plus or minus the square root. B squared is 2 squared, which is 4, minus 4 times a, which is 3, times c, which is negative 3, all over 2a. Well, a is 3, so 2a is 6. Now we simplify. Negative 2 plus or minus the square root of 4. So here we have 4 times 3, which is 12. 12 times 3, which is 12 times 3 is 36. And we're subtracting a negative number, so this becomes plus 36 all over 6. Keep going. Negative 2 plus or minus the square root. 4 times 36 is 40 all over 6. Okay, and now here's where you need to use your calculator. Okay, and the directions say round to the nearest 10th place. So we're going to do negative 2 plus the square root. So you type in the square root of 40 in your calculator, hit equals, then hit divided by 6, hit equals, and we get here x equals 0.72. Okay, I'll round to the 100th place. The other solution, if I use the negative sign, is going to be negative 2 minus the square root of 40, hit equals, and then hit divide by 6, and I get negative 1.39. Okay? And so these are my two solutions according to the quadratic formula. Now, if I go back to the original problem and I think about trying to factor this here, there's no way I'm going to be able to factor this into two pieces. So like say I have a 3x here, I could put a 3x and an x, but I need a 3 and a 1, I could put a 3 here and a 1 here. It's not going to work out and give me the things that I want because the answers came out to be nasty radicals, which led to nasty decimals. So there's no way you're going to be able to figure this out just by factoring by hand. So being able to use this quadratic formula, which is a kind of an easier way to do this than completing the square and then working backwards, is going to be super, super useful and valuable. Alright, let's go ahead and do one more. Let's try to do number 5, see what happens here. The first thing that's important to notice with number 5 is that it's not in standard form, and therefore we have to first get it in standard form. So let's go subtract 10 on both sides, and we get 3, let me draw a line here, 3x squared minus 13x minus 10 equals 0. So I can identify my a is 3, my b is right here, negative 13, and my c is negative 10. Okay, now I can plug these in the formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now we plug in our numbers. Negative b, well b was already negative 13, so that's going to be positive 13, plus or minus the square root b squared, 13 squared, you can use a calculator if you need to, but I'll just tell you it's 169, minus 4 times a, which is 3, times c, which is negative 10. Okay, divided by 2a, a was 3, so again we have a 6 right here. Keep simplifying. 13 plus or minus the square root. Okay, 4 times 3 times 10 is, 4 times 3 is 12, times 10 is 120. Minus a negative becomes positive. 169 plus 120 is 289. Okay, so here you can pull out your calculator. It turns out 289 is actually a perfect square. It's a perfect square of 17. Okay, so we can write x equals 13 plus or minus 17 over 6. And now we have to branch, because there's two possibilities. 13 plus 17 is 30. 30 divided by 6 is 5. Okay. 13 minus 17 is negative 4. Negative 4 divided by 6 reduces to negative 2/3. Okay, so there's our answer. So interestingly enough, this came out to be a whole number, and this came out to be a fraction, but with simple coefficients, simple numbers there, right? So if we would have tried to factor this guy, it seems likely that we would have actually been able to do so. Because if these are the two roots, it would have been able to factor into something like this. X minus 5, because if x equals 5 is a root, it had to come from x minus 5. Then here what we have x minus a plus 2/3, because of this negative 2/3, opposite sign right there. So if we would have had this as our factored form, the solution would have been this. And then there's a coefficient of a 3. The a value is a 3. Right, so this right here would be the factored form that we could have got. And if we distribute the 3 in right here, you can see this would be 3x plus 2 times x minus 5. So it's possible that we could have solved this one by factoring instead of the quadratic formula, which is why at the very beginning of this whole lesson or in class, I want to insinuate to you guys that the quadratic formula, while it's great, it's not your automatic go-to. Okay, so you should first try to solve using factoring. And if you can't find an easy way to factor it, then you can go ahead and jump to the quadratic formula. But it shouldn't be your starting place. It should only be your kind of last resort backup if nothing else seems to be working. Alright, I'll see you in class.